Okay, so x squared minus 4. First step, change the f of x to a y. So y equals x squared minus 4. Okay, step 1, change the f of x to a y. You should be making little side notes here. Okay, second step, we're going to swap the y and x. Okay, just the letter, leave the exponent where it is. So we're going to swap now, or interchange the x and y. So x equals y squared minus 4. Okay, do not bring the exponent with the x. We're just changing the letters themselves. So again, step 1, we change f of x to y. Step 2, change the x and y. Step 3 now, we're going to solve for y. What is the first step now to solve for y? First step. Add 4 on both sides. Good. So we're going to add 4, or if you prefer, bring it over and it becomes plus. That's fine. So add 4 on both sides. I'm going to bring it down here just so it's out of the glare. So we have x plus 4 equals y squared. Okay, last step for solving. Last step, what would it be? Square root. Good, so we square root both sides. Okay, because square rooting is the opposite of squaring, so the squaring crosses off. So we're left with y. I know I'm switching the side, so y equals the square root of x plus 4. So the square root function is the inverse of a square or quadratic. Okay, last step, change the y back into f at x, but now it's the inverse. So f inverse of x equals x plus 4. Okay, so y equals square root of x plus 4. Again, now we're going to change this is the last step, step number 4. Change the y into an f inverse of x. Step 4. Okay, I'm just going to erase this part here. Okay, part B says graph the function and its inverse. Okay, so I showed you a quick one on how to graph last week. Okay, so let's graph this one. Okay, let's just graph the parent function, and then we can take the points and swap them. Okay, so this is quadratic. A quadratic, the parent function starts at 0 and 0. Okay, but this one, it's not just x squared, it's minus 4. So what happens to our graph? X squared minus 4, what happens to our graph? start at -4, it starts at -4, good. So on the y-axis, right? So we move down 4 spots. Okay, so instead of being at 0, 0, it's now at 0, -4. If you're not sure, plug in 0. 0 squared is 0, -4 is -4. Okay, so we have it here at -4. Okay, I'm not sure if I did it in this class or the previous one, but I know it's in the video. The quick way to graph a quadratic that does not have a stretch or compress. You go 1 to the right, 1 up, 1 to the right, 3 up, 1 to the right, 5 up. Okay, and now you do the opposite. Okay, 1 to the left, 1 up, 1 to the left, 3 up, 1 to the left, and 5 up. And we have our quadratic. That only works if your a value is 1. Okay, so graph f of x, so graph the function and its inverse. So now we're going to swap the points. So 0, -4 becomes -4 is 0. 1, -3 becomes -3, 1. 2 and 0 becomes 0, 2. And 3 and 5 becomes 5 and 3. Okay, so instead of facing upwards, and now faces sideways. Okay, so you might be asking yourself something. We just learned the square root function 2 days ago. Sorry, on Friday. We just learned about the square root function Friday. So this inverse is a square root function. But this doesn't fully look like a square root function. Okay, so a square root function should just have this one arm. Okay, so this is what we're going to do. If you're asked to graph a square root function, just do the one arm. If you're asked to do the inverse, you're going to include both arms. Okay, what I mean by arms or branches is these here, so the arms are here. Okay, so if I'm doing the inverse, if I'm graphing the inverse, I'm going to include both of them. Okay, if you're just asked, or like in a question, graph a square root function, you're just going to graph the one arm. You're not going to include the negative arm. Okay, but if it's asking you to do the inverse, we obviously just swap the points. So we have two arms in the inverse function. Okay, which includes their positive and negative answers. Okay, so make sure on a test, if I ask you to do square root, it's just this. But if I'm asking you to do an inverse of a quadratic, the inverse of a quadratic is a sideways parabola. Okay, we're including both arms. Okay, so that's the graph. C, is the inverse a function? So looking at the graph, is the inverse a function? No. Okay? If it was just the one arm, it would just be the one arm, it would be yes, but because that would be like a square root function, but this is not. Okay, we have both arms. It doesn't pass the vertical line test. So the vertical line test, it touches more than 1 point. Okay, so it does not pass the vertical line test, so therefore it is not a function. Okay, so lastly, we're going to do the domain and range. So let's do the domain of the parent function. Okay, all quadratics, the domain, once again, is XER. Unless it's a real life question and have restrictions. Okay, XER. Our range, YER. Okay, what's our range with the parent function? That means, or the function. What's the range of the function? So the black one here. Y is greater than -4, okay? A little bit better. Missing something? Okay, don't forget the equal to. So greater than or equal to -4. Yeah, you guys got it. Equal to Esther and Christian. Okay, so then it said determine the domain and range of the function, f of x, the function, and its inverse. Okay, the easy part of this one is the inverse is just you just swap it. Okay, because remember the x's are the y's and the y's are the x's, so it just switches. So this becomes the domain of the inverse, and this becomes the range of the inverse. So for the inverse, the domain is XER such that x is greater than or equal to -4, which makes sense because they're inverse. It's cut off here. So it goes from -4 onwards. And our range is just YER. So this is for the inverse.